combination of capacitors is set up as shown in figure. Magnitude of the electric field due to a point charge capital Q having a charge equal to summation of charges on 4 microfarad and 9 microfarad capacitors at a point distance 30 meter from it would be equal to. Now this problem as such requires some unconventional thought process. Very simple though, but it says that we want to find electric field at distance of 30 meter, and that too due to some charge Q. This charge Q can be obtained from the charge that would appear on the 4 microfarad and 9 microfarad capacitor in this combination. So that is what is unconventional in this problem. But it can be solved easily, and we can see that these are in parallel combination in series with this, and overall this entire is in parallel combination with this. Students can easily solve this, and making use of that series parallel combination, the equivalent capacitance of the system comes out to be 5 microfarad. This 5 microfarad capacitor will draw some charge from this 8-volt battery, and we can say charge drawn Q will be equal to C into V. So that total charge drawn, let us say Q dash, is equal to C, that is 5 microfarad, into V, that is 8 volts. So 40 microcoulomb of the charge would be drawn from the battery. This 40 microcoulomb charge which is drawn from the battery will be splitted up into two parts in these branches, as we can see, and part of that charge will appear on 2 microfarad capacitor. Voltage on 2 microfarad capacitor is again 8 volts, so we can get value of Q2. This Q2 value comes out to be 16 microcoulomb. So out of 40 microcoulomb, 16 microcoulomb charge appears on this, so remaining would pass on to the upper layer. We can say that that would be from conservation of charge 40 minus 16, 24 microcoulomb charge. 4 microfarad capacitor will be using this 24 microcoulomb charge, whereas these two capacitors will be having the sharing of charge. In order to get what is the share of charge for this capacitor, we can make use of simple combination, because we know that voltage across this is going to remain constant. So it can be obtained by a simple formula that charge appearing on any capacitor is equal to its capacitance divided by total of capacitance into the total charge which is entering. So if you want to find the charge on this capacitor of 9 microfarad, then we can simply write capacitance of the 9 microfarad capacitor divided by total capacitance, that is summation of these two, into total charge that is entering, so that is equal to Q4. On solving that, we get it as 18 microcoulomb. So now the total of this Q4 and Q9, that would be equal to 24 plus 18, so it is 42 microcoulomb. It is said that this summation of charge would be the charge which is going to produce the electrical field at 30 meter distance. So now, making use of that formula of electric field of a point charge, E is equal to K, that is 1 upon 4 pi epsilon 0, into the charge, so that is summation of this to charge divided by square of distance from the point to that charge. On solving that, we get an easy simplification, and it comes out to be 420 Newton per coulomb. So correct option in this case is option C.